We're going to finish this chapter up by looking at what most perceive to be the most challenging part of organic chemistry, and that is synthesis. So we're going to just get our feet wet and look at a couple of examples in this chapter, but just be warned, when you get into Organic 2, synthesis is going to become a really important portion of the course. So what you're doing is using your knowledge of reactions to prepare a complex molecule from simpler starting materials. So what we want to do in this case is start with acetylene and figure out what reactions we need in sequence to get to this aldehyde product. There's no magical way to learn or study for synthesis. The key is knowing your reactions forwards and backwards. If you have a really solid understanding of reactions, you're not going to have any problem with synthesis. If you're struggling with synthesis, that means you don't know the reactions. So by knowing reactions, the way I would tackle this problem is to look at it and say, well, the product here is an aldehyde. And one of the key ways we can get to an aldehyde is through a hydroboration oxidation. The other thing I look at is the fact that we've added carbons. And we've added, if you look, we have 2 carbons in the alkyne. And one of those carbons can become the aldehyde, and then there's the second carbon. So what have we added? We've added 3 carbons to the chain. How do we add carbons? Through an alkylation. Let's actually work this kind of backwards. And what I mean by that is starting at the product and thinking about what it came from. When we think backwards, we use an arrow that looks like this. This is called a retrosynthesis arrow. And when you hear retrosynthesis, that just basically means you're thinking backwards. So for this, the aldehyde would have come from the enol, because it's the enol that tautomerizes to the aldehyde. So let's draw the enol. And then that enol would have come from hydroborating the alkyne. So now let's keep going backwards and think about the alkyne that this would have come from. This alkyne. And then this alkyne would come from acetylene through an alkylation. So what you want to do after you kind of figure out the basic steps, write this in the forward direction. In the forward direction, we would start with acetylene. First, I'll do the alkylation. I'll add a base, NaNH2, and then I need a 3-carbon chain added. So I'm going to add 3 carbons, and a halogen, I'll use chloride. So that puts the 3-carbon chain onto the triple bond. Next, I need to do the hydroboration oxidation. When we do that, it gives us the enol, which is shown up here, and then that enol tautomerizes to the aldehyde. Again, if you want to keep your atoms highlighted where they're coming from, those 2 come from the triple bond, which come from acetylene. These 3 come from the organohalide through the alkylation reaction. Let's try one more. And here we have an epoxide, and I really should have put plus the enantiomer because this reaction sequence would form both enantiomers. And if you look at the epoxide, we know only one way to get to epoxides, and that's through an MCPBA epoxidation of alkenes. So what we're trying to figure out is, well, how do we start with this alkyne, do some steps, and get to this epoxide? So this is another good case of working backwards and thinking that, okay, I know if we have the alkene on these two carbons, we can do the epoxidation. So there's the alkene that would come from. And we want this to be the transalkene because it's a transalkene that would leave these groups opposite and just give us the epoxide as the wedges or dashes. We can get to the transalkene through the reduction of an alkyne. So again, working backwards, this alkene can come from the alkyne. And then this alkyne can come from alkylating the starting material. So there's our alkyne and how it ends up eventually in the product. So now we have our strategy. Let's write this out in the forward direction. We'll start with our terminal alkyne, add a base. This time I'm going to use sodium hydride, something different. That's sodium plus and H minus as the base. And then follow that by, we need 2 carbons. So to add 2 carbons, I'll add ethyl bromide. There's our alkylation product. Now we need the transalkene. For that, you want to use the dissolving metal reduction. So use sodium, ammonia, low temperature. So there's our transalkene. And then finally, we can get the epoxide from MCPBA. So there's that, and you would get the enantiomer as well.